here to discuss the science of sea level rise and climate change, we have our moderator, Nathan Phillips. That's great. Professor of Earth and Environment here at BU. Nathan is joined by Scott Doney, senior scientist at the Woods Hole Oceanographic Institute, who has an expertise that spans oceanography and climate, with a focus on how ocean ecology responds to natural and human-driven climate change. He was an author on the 2014 U.S. National Climate Assessment. Erika Spanger-Siegfried, senior analyst for the Climate and Energy Program at the Union of Concerned Scientists, and the former manager of the Northeast Climate Impacts Assessment. And lastly, we have Josh Willis, project scientist at the NASA Jet Propulsion Laboratory at the California Institute of Technology, and a lead author for the 2014 National Climate Assessment released by the Obama administration. Thank you all for being here, and I'll let Nathan start.
Thank you, Beth. Well, very excited to be here, and following Bob Oakes yesterday, I feel like it's a tall order to moderate a session. He was excellent, so I'll try my best. And we'll work in reverse alphabetical order with our speakers. They'll each come up and give some remarks with a little bit of PowerPoint, maybe. And just in terms of how we will work it here, we have Sarah Hill, our excellent timer, and she will give the speakers a little wave at 5 minutes, and then at 9 minutes each. And then we will have some questions if there's time after that, and maybe some from the audience as well. We'll see how the timing goes. So we're going to start with Josh Willis. Thank you.
I don't have any PowerPoint slides. You're in luck because I don't have any PowerPoint slides. And I have my own timer, too. Thank you, Nathan. It's really a pleasure to be here, and I just want to say thank you, too, to the panelists and everyone from last night. If you weren't here last night, there was a really fantastic discussion on impacts of sea level rise on cities, and it was really excellent. So I want to give you a little bit of an overview of the sea level rise issue, and I'm going to start with the story of sea level rise, which really begins 20,000 years ago, at the end of what paleoclimatologists would call the last glacial maximum, and what Hollywood would call the last ice age. Now, this was a period when the Earth was substantially cooler than it is today, and enormous ice sheets filled much of North America. Not filled it, but there were at least 2 miles of ice in some regions of North America. So an enormous ice sheet really covered a huge part of our country back then. So it was a very different landscape, and it was a very different climate. And prior to that, actually, this cold period lasted many tens of thousands of years. And if you look at the history of the human race, we've pretty much been evolved into the kinds of folks we are now for about 100,000 years. But we really didn't begin to build civilizations until we warmed up out of the last ice age, and we're able to begin farming and to begin settling the civilization that we built today. So our modern civilization is really only about 10,000 years old, and a lot of that has to do with the fact that the climate prior to that was too variable and too hostile to really settle in and develop farming and civilizations and nations, and ultimately iPhones, right? The most important technology of all. So really, we owe a lot of our current affluence and technological prowess to about 10,000 years of a fairly stable climate. So what was it like at the beginning of that, prior to that? About 20,000 years ago, we were at what was called the last glacial maximum, and during that time, sea levels were about 120 meters lower than they are today, several hundred feet lower. And the reason was simple. It was colder, there was a lot more ice. That ice, which sat on land, came from water out of the oceans. So as that ice began to heat up, the water from the ice sheets ran back off into the oceans, and we saw about 10,000 years of what in some cases was very rapid sea level rise, 10 feet per century in some cases. So we really have seen past sea levels rise very quickly, but not during the time when we've had an established civilization. So 5 to 4,000 years ago, sea level rise began to slow. We began to warm up into our current warm period of the global climate. And our sea levels stabilized. And really for about the last 2,000 or 3,000 years, we've not only had a very stable climate in terms of temperature, we've had a very stable rate of sea level. In other words, we haven't had to retreat from the coastlines like we may have had we had civilizations 20,000 years ago. So modern day sea level rise really began around the time of the Industrial Revolution. About 150 years ago, humankind began to take the reins of global climate. And today, in terms of the global climate, we are the most powerful thing driving climate change. Human emissions have increased enormously in the last 150 years, as Tony showed us in some of the graphs. And really, now we are the dominant source of climate change on the planet. So think about that for a second. For thousands and thousands of years, humans existed, began to build civilizations, but really it's only in the last 150 that we began to drive our climate out of what was already a warm period into a much, much warmer period. And one of the consequences of this warming is global sea level rise. Now, I'm an oceanographer, so I tend to think in terms of a kind of an ocean-centric world, but I'm very justified in that because remember, the oceans cover 2/3 of our planet's surface. So if something is changing in terms of the global climate, one of the most important places to look for it is really in the global oceans. And what we see when we look at the global oceans is a rising sea. We see the volume of the oceans increasing at a pace faster now than at any time in the last 2,000 years. And we know this from direct records of sea level up and down, in fact, the east coast of the United States. We can now say, without any real doubt, that sea levels are rising today faster than at any time in the last several thousand years, and the cause is human-driven global warming. So we know that humans are trapping extra heat on the planet by changing the composition of the atmosphere, and over 90% of that heat is trapped in the oceans. So think about that for a second. 2/3 of the planet is covered by oceans, and 90% of the heat that we trap from global warming is actually warming the oceans. You know, we often think about global warming as something that's happening to the atmosphere, but really, global warming is almost entirely in the oceans. And one of the consequences of that warming is a rising sea. Because water, like many other materials in the world, it expands as it warms. And so about 1/3 of global sea level rise today is just from the extra heat that's being absorbed into the oceans. The rest of it is because of melting glaciers and ice sheets. And as Tony mentioned before, these are contributing about 2/3 to global sea level rise. And they come from different sources. There's lots of small glaciers around different areas in North America, South America, really all over the world has small glaciers, and these have been melting fairly rapidly and contributing significantly to sea level rise. But the elephant in the room in terms of global sea level rise is really the two great ice sheets that still remain today, one in Greenland and one in Antarctica. And these two are already contributing about 1/3, maybe a little bit less today, but about 1/3 of the sea level rise that we see today. But what the real question is in terms of looking into the future is what are these ice sheets going to do as we continue to heat up the planet's atmosphere and heat up its oceans? In fact, a lot of the ice in both Greenland and Antarctica sits below sea level. That means that the land in Antarctica and Greenland actually is deeper than sea level, and the water has the opportunity to run right up to the ice sheet and interact directly with the ice on the land. So as that water warms, it has the potential to melt away the ice essentially from below. And it's these kinds of processes that we really look to in terms of trying to ferret out how much sea level rise we're going to see in the next 100 years. Tony showed the graph of the sea level rise projections in 2100, and they ranged from 1 to 6 feet. And most of that uncertainty, most of that huge window is due to the ice sheets and our inability to predict what they're going to do in this warming climate. So these are very complicated systems, but they're also systems we haven't had the opportunity to observe in retreat. We haven't really had the opportunity to measure these things disappearing because they've only begun to do so in the recent history. And that's only because of human-caused warming. So I want to take just a couple more minutes, or I'm going to take a minute and a half, I'm watching the time too, and talk just a second about NASA's role in this. I work for NASA. I'm a climate scientist at the Jet Propulsion Laboratory. And we have a couple of satellites that have a bearing on sea level, one of which is called the JASON mission. And the JASON mission, which is a series of satellites, measures the height of the ocean from space with an accuracy of about 1 inch from 800 miles up. And so it's an incredible technological feat, but it also measures the ocean in a comprehensive way. We get a global look once every 10 days. And what you see when you look at the global oceans is this rise that is slow, steady, and really unequivocal of about 1 inch per decade today. We also have satellites that look at the ice sheets that measure the disappearing mass from places like Greenland and Antarctica. But what we don't have at NASA is a satellite that will tell us the future, although we're working on that. Really, the future, though, for sea level rise is up to us. A lot of the uncertainty in the future projections of sea level rise is not just about what the ice sheets are going to do, but about what we are going to do in terms of mitigating our impact on the ice sheets and on the planet's climate. And with that, I'll stop. Thank you.
I'm sure you may have some questions, and I do too, for Josh and the panel. But I think what we'll do is we'll just move through the speakers and then have a discussion period toward the end. So we'll have Erika Spanger-Siegfried join us next. Thank you.
Morning. Thanks, everyone. So it's really fun to follow Josh because we're going to be going from this grand sort of sweeping historical scale down to the next 15 and 30 years, really practical time frames, the lifetime of a mortgage. And I want to talk about tidal flooding in those time frames. And I'm really glad to have the opportunity to speak to our new work here today because I think that tidal flooding represents a critical gap that most of us have, that I certainly had, about what sea level rise means for our communities in the near term. So it's a subject that we explored in some depth in the report that you see here, and I would really invite people to take a deeper look. And what we found is both really obvious on the one hand. Tides, high tides are the leading edge of the sea, essentially, and we should expect them to reach and impact our communities first. But what we found is also really surprising in the pace and extent of which we expect that change to happen. So I'm going to try to boil down this 76-page report into just a few key takeaways. I want to touch just very, very briefly on a couple of our findings. I'm going to invite you to watch a quick video, and I'm going to leave a lot unsaid, and hopefully we can dig into some of that in the discussion, which I'm really looking forward to. So this is a photo of Salem, Massachusetts, just a few miles north of where we are. It happens to be where I grew up, my hometown, right near that power plant and a block from the ocean. My family still lives here. I happen to like this photo, but this really could be anywhere on the East Coast for the most part. We have put as much as we possibly could, as close as we possibly could to the shoreline. Since doing that, we have learned about sea level rise. And we've learned two really important things about sea level rise, as Tony was speaking to earlier. On the one hand, we've learned that sea level rise is poised to permanently inundate certain low-lying areas later this century, so certain places visible in this photo. And we've also learned that sea level rise is making our storms that much more powerful, particularly when they strike at high tide. And the general public is starting to get this too. So there's this growing awareness of sea level rise risk. You know, there's the current risk associated with storms, and then there's the long-term risk associated with permanent inundation. But we know that sea level is rising at an accelerating rate in between. So it really begs the question, what does that in between look like? How does that change unfold? What should we be planning for? What should communities be expecting in just the next couple of decades? So it's those questions that we took a hard look at in our report for both the East and Gulf coasts, and we found that tidal flooding is poised to play a very central and disruptive role. So I want to talk just really, really briefly about tides. Folks in this room are probably quite familiar with them. They rise and fall twice a day here on the East Coast. And twice a month during the new and full moons, the combined gravitational pull of the sun and the moon drive those tides higher than normal. And those are often called spring tides. A couple of times a year when the moon is closest to the Earth, that whole phenomenon is amplified and we get even higher tides, what are often called king tides. For the purposes of this discussion, we're just going to lump them all together. We're going to call them extreme tides. And I want you to look at the extreme tides that Lewis, Delaware, in October of 2011 experienced. So what you see here is when tides reach these extreme levels, they can start to exceed local thresholds for minor flooding as well as moderate flooding. Minor flooding is often considered a nuisance, but it can do damage. Moderate flooding is considered the level of flooding that can cause a risk to life and property. And it's important to note that this is happening without wind, without rain, without storms. This is just the tides. And I want to share sort of an iconic photo from New Hampshire. Folks may have seen this. This is coastal New Hampshire at dead low tide, and that same area during a king tide. So the point is simply that the tides are capable on a sunny, windless day of reshaping the contours of usable land, and we need to be preparing for that. So as sea level is rising, that kind of flooding is happening more frequently. This chart just shows you a handful of locations and their sea level rise, local sea level rise since 1970, as well as the number of days by decade where tidal, with tidal flooding events. And you can see a pretty clear sea level rise driven trend in these locations. This is echoed by a recent NOAA study, which folks might be familiar with on historic flooding. So we know that sea level rise is accelerating, and again, it begs the question, where is this going for these coastal communities? I actually want to skip this next slide and get right to the video. We could come back to it if need be in the discussion, but we know that if you don't live in a community that experiences tidal flooding, that this can be sort of abstract. It can be hard to appreciate what this really means. So you see us put together a very, very short video. We released it just last Friday.
The ocean rises, streets submerge, neighborhoods flood. There is no storm, there is no wind, there are only the tides. And when the tides rise highest, they are flooding communities up and down the East Coast. From Miami to New York, Norfolk to the Jersey Shore, it has simply become a fact of life.
Tidal flooding on this island happens definitely once a month. During normal tidal flooding events, which occur with a full moon down here at this end of the block here, you could see the water up to my knees if we had an east wind, and that would just be a normal occurrence. Any cars that are here during the event will get flooded, destroyed. The children can't get off the block in time for school.
The tides are reaching higher, and tidal flooding is expanding because sea levels are rising. And sea levels are rising faster as global warming heats up the planet. Hotter temperatures are melting glaciers and ice sheets into the sea, even while global warming is heating up the ocean itself.
Water, when heated, expands, and sea level has got nowhere to go but up. So most of the sea level rise we're seeing the last 50 years, which is 8 or 9 inches in this area, is due to the ocean getting warmer and getting bigger.
We're seeing significant impacts of sea level rise already here in South Florida. And that's not something that was happening 50 years ago. And so we know that a new flooding is connected to sea level rise. And we anticipate with the projected flooding, we're going to have more days of flooding than we're going to have days where we don't have flooding.
Over the next 30 years, sea level could increase a foot or more in many East Coast locations. With only a moderate increase in sea level, dozens of communities could flood at least 24 times a year, or an average of twice each month. A growing number of locations could flood 100 times or more every year, some more than 200 times, including portions of Washington, D.C., Atlantic City, and Miami. And when storms occur, the higher tides will only magnify the risk of severe coastal flooding events. All along the East Coast, communities may be at risk as the encroaching tides render areas effectively useless.
I think that regardless of your total position on this, that there is no way to avoid the fact that we are seeing more significant events in terms of flooding, tidal issues. We have to get together, everybody on the same page, and take measures that are doable measures.
Globally, we have to restrict emissions, which we're all trying to do, but not very successfully. We've got to cut down the carbon in the atmosphere because that's the prime cause.
People often think about climate change impacts, especially sea level rise. It's something that's going to be in the distant future. But all the current research shows that it's something that's going to be well within our lifetime and certainly in the lifetime of our children. And so there is no future date where you can take action. You have to take action now.
Dan is from New York City. Nicole is from Miami. Those cities represent what we call tidal flooding frontline communities, and there are many others: Annapolis, Norfolk, Savannah, Charleston, places up and down the East Coast that experience tidal flooding on a significant enough basis today that it's disrupting daily life in affected flood-prone areas. We expect in the next 15 years for that front line to expand to other communities, including Boston, and that by 2040, communities that are currently unfamiliar with tidal flooding will begin to experience it on a regular enough basis that they will need to begin to cope. So the trend is that tidal flooding is going to become widespread, frequent, and increasingly disruptive. So this is a version of the animation you saw in the film, and it is showing us 2045 results. These are tidal flooding events per year. This does not distinguish between minor flooding events and moderate flooding events. And I want to point out that we were only able to look at 52 locations along the eastern Gulf coasts that had tide gauges that we could use. So the fact that there are large stretches here where you don't see these circles does not mean that tidal flooding isn't an issue there. It just wasn't possible to include those places in our analysis. But the fact that every place we did look at, by and large, showed these increases tells us that locations in between need to start thinking about tidal flooding as well. So just a few quick closing thoughts. Our analysis projects tidal flooding in the absence of a human response. So the extent to which a community is actually impacted by tidal flooding depends to a certain extent on what it does in response, in preparation, and what we do as a country to support vulnerable communities. But I want to be clear that the projected frequency, extent, and duration of this flooding it has the potential to create major and potentially costly disruption, or major and potentially costly adaptation responses, and in either case needs to be taken quite seriously. And though sea level rise and a certain amount of tidal flooding are more or less guaranteed in the near-term time frame of this analysis, we obviously have a say in the changes we put in motion later this century and beyond. And as we know, grappling with climate change and working to slow the rate of acceleration of sea level rise is probably the most effective way of protecting coastal communities over the long term. I'll leave it there.
Thank you, Erika. Scott Doney from Woods Hole Oceanographic Institute.
Thanks. Good morning. I wanted to come back to some of the themes that Tony raised earlier today, that sea level is one aspect of climate change, but we're seeing multiple aspects or facets of global warming. And particularly for coastal communities, we're seeing sea level rise, but also ocean warming, less sea ice during the winter in some parts of the world. But one of the other things is that we're seeing changes in rainfall patterns and storminess. And this can exacerbate sea level rise by increasing storm events and inundation events. In particular, a warmer ocean evaporates more water into the atmosphere, and we're strengthening the water cycle. But perversely, it's not ending up a globally uniform distribution. So places that need more rainfall are not going to get more rainfall. Places that already have a lot of rainfall will probably get more rainfall, and it will likely come in more intense events. So for example, over the last several decades, the Northeast of the United States has seen increased rainfall, and it's also seen an increase in very intense precipitation or rainfall events, and an increase in flooding. So the top panel here shows those intense precipitation events. The bottom panel in the green shows increases in flooding. And as Tony noted, we're also seeing drought and less flooding in the southern part of the United States. Some of this comes in large storms. So this is a picture of Hurricane Irene. And we often think of tropical storms as being important for changing sea level locally and storm surge, the winds and the low pressure driving water onto the coastline. But they are also very important for flooding inland. And in many cases, many coastal communities are going to be hit from both sides. They're going to see during these storms higher sea level, but also runoff from rainfall on land, where you can get very intense rainfall during these tropical storms. Now, one of the interesting things is as you increase the amount of heat in the ocean, Josh talked quite eloquently about the fact that most of global warming is actually ocean warming. That's going to increase the energy that's available for these tropical storms. And in fact, you can think of tropical storms as being really driven by the amount of heat in the upper ocean, because that's where it taps that heat to keep the storm going. That's where the energy comes from. So in the future, we expect to see, because the ocean warms, an increase in perhaps the frequency of storms, but particularly the intensity of storms. We'll see stronger storms with larger impacts impacting coastlines around the world. Another factor that we haven't really talked about is, Josh and Tony talked about sea level rise. It's not globally uniform. The ocean's warming, we're melting land ice sheets and glaciers, but there are also factors that cause regional sea level changes. And so in particular, because of winds and ocean currents, the sea level right along the East Coast is actually lower than it would be. You can see that in the upper panel. There's a band of blue and purple along the East Coast of North America. That's actually relatively low sea level because the winds and the Gulf Stream basically affect the topography of the surface of the ocean. And what may happen in the future because of climate change and a slowing of the Gulf Stream in the lower panel is you actually see this shift where that strong boundary between low sea level right near the coast, high sea level offshore starts to relax. And we may see additional sea level rise along the northeast coast up into maritime Canada because of changes in climate. So in addition to global sea level rise, we may see regions of accelerated sea level rise along the East Coast associated with changes in the Gulf Stream. It's been mentioned that the ocean is warming. I just wanted to pull this out. This is some of the temperature data from a very recent warming event, 2011 and 2012. Saw the warmest seawater temperatures ever recorded along the US East Coast for the region basically from Cape Hatteras all the way up to Newfoundland. And you see in this panel that it's occurring both right along the coastline, up into the Gulf of Maine, and also offshore near the Gulf Stream. this was associated not just with climate warming, but with shifts in wind patterns. We hear a lot in the news now about the polar vortex and changes in the jet stream. Well, as climate changes and as the Arctic warms up, we are expecting to see changes in the air circulation patterns, and how much cold air gets brought down from the Arctic and Canada may be changing over time. This was a winter that got very few of these cold air outbreaks coming down into New England, and as a result, the ocean stayed warm throughout the winter and into the spring, which is having big impacts, as Tony mentioned, for example, on energy use, but also on marine ecosystems. The plants and animals that used to live south of New England are now migrating northward, trying to maintain their same temperature regime. They like a certain temperature regime just like we do. And so what we're seeing is a shift in the ecosystems where we used to fish stuff south of New England or off of New Jersey. Those fisheries are now migrating into the Gulf of Maine, and some of the traditional fisheries in the Gulf of Maine are disappearing because it's no longer warm, it's no longer cold enough there to support many of the fish species that used to reside there. I do just want to touch on one or few other issues that are affecting coastal communities beyond sea level rise. One of the topics that I work on is something called ocean acidification. Beyond just changing the climate, our large emissions of carbon dioxide to the atmosphere, shown here in red, this long-term record of rising carbon dioxide levels, is also, Tony mentioned that about half of that carbon dioxide is being removed either into the ocean or into plants. And that fraction that ends up in the ocean is actually changing the chemistry of the sea. It's making the sea more acidic over time. And as this ocean becomes more acidic, it makes it harder for many plants and animals to build their shells and skeletons. Things like corals, shellfish, clams, mussels, oysters, even many crustaceans have shells that have calcium carbonate in them. And under a more acidic world, a more acidic ocean, more carbon dioxide levels, we expect to see large collapses, particularly in coral reefs and in many shell fisheries. So in addition to the human-built infrastructure, the ecosystems that provide many services to our coastal communities are also threatened, both from warming and from acidification. So I'll stop there, and then we can have a discussion with the panel.
So from Tony Genados and our speakers, if it wasn't clear before this session that sea level rise is here now and going into the future, I think our speakers have made it abundantly clear that the evidence and impacts are here and they're serious. I have a bunch of questions and responses to what I've heard here today, but I'd like to just open it up to the audience and get your questions. So let's start there, and we'll move to some of my questions if there's a break. So we have a number of questions. Here's one right here. The mic's coming, so.
Josh, I have a question for you. I was so excited to hear somebody from NASA.
Let's make sure the mic is on.
Is it on? Is that good?
Yeah.
Josh, my question for you. It was so great to hear somebody from NASA talk about the oceans, because every time you hear about NASA, you think, space exploration. So I'm just curious to know if NASA's going to, flip that and start taking a deeper dive into oceans and make it more, public, and do some kind of a PR move on that, because I think you've got a lot of power, but it always seems to be up in the sky as opposed to in the oceans.
Is my mic on? Can you guys hear me? No? If you'd like to write a letter to Charlie Bolden, the chief NASA administrator, I'd love to. I would greatly appreciate that. Of course, NASA has a lot of irons in the fire, and it feels a huge responsibility to kind of inspire a sense of exploration. And so you see missions like the Mars rover get huge amounts of media attention because they really capture people's imagination. And that's important. But at the same time, I agree. I really think that one of the most important things NASA does is turn its eyes on Earth. And we do a huge amount of research and exploration, as it were, of our own planet from space. There's a fairly robust observing system that measures all kinds of things about the Earth. But you're right, we could stand a little bit better press.
Here's a question. Emily.
Hi. So my question is for you, Erika. Yesterday we heard about how cities are specifically working on resiliency. We didn't really hear so much about local towns that are affected by the tides. Do you think that they're going to try and move more towards resiliency, or do you think that they're going to push back, like more further inland?
Retreat from the shore? That's a great question. I think, personally, I think that resiliency is a pretty broad and inclusive term that will be, what it means to be resilient in a specific community will involve some combination of defending and accommodating the waters and retreating. It will be very place specific. When it comes to tidal flooding, I'm really curious to learn more about the overlap between the defensive and accommodating measures that deal with storm surge as well as tidal flooding, because they're not perfectly overlapping. And I feel like tidal flooding needs to be taken very seriously, as you've heard from me today. But it's not clear that the measures we're bringing online for storm surge protection, which ought to be the priority, I don't quibble with that at all, also serve this tidal flooding purpose. And given how difficult it is to get infrastructure funds, we ought to be spending them wisely and getting as much protection out of them as we possibly can. Answers.
Question here.
I'm Julie Wormser from the Boston Harbor Association. This is fabulous. I just had questions about the uncertainty. Basically, we've been looking at 3 to 6 feet of sea level rise by the end of the century around Boston. Can you help me understand how much uncertainty there is around the Gulf Stream, changes in the current, what's the gap between where we are now versus flat sea level? And then also how much kind of the range of uncertainty around Greenland and Antarctica. I think the numbers we're using are not including that ice sheet melt. I guess I want to understand to what extent are we good with those numbers versus that would be way off if blah, blah, blah.
I can start with the Gulf Stream if you want to.
Go for it.
We know that the Gulf Stream changes the topography of the surface ocean. The idea is that under a warmer world, it might weaken. And right now, we're just putting in the observational methods to really document that. We see short-term variations, but we don't have the records like we do for tide gauges to document long-term trends. So I say right now that's one of those risk factors, but I wouldn't say it's a certainty.
I think you can put in the ballpark Gulf Stream related sea level changes are 10 to 20 centimeters, so 4 to 8 inches. Uncertainties due to things like the West Antarctic ice sheet collapsing are 50 centimeters. They're 1.5 feet or more. So really the huge uncertainties, the biggest piece of the uncertainty pie is West Antarctica and to a certain extent Greenland as well.
Can I add to that?
Yeah.
Just from a planning perspective, and Julie, you're probably really familiar with this, but NOAA, when it developed its sea level rise scenarios, had the intermediate low, intermediate high, and the highest, and they advised people to choose a scenario based on the risk tolerance of the decision at hand. And I'm a little hard-pressed to imagine decisions involving, municipal infrastructure that don't have a relatively low tolerance for risk and wouldn't require, given how long-lived they are, looking at those higher ranges.
Yeah, I think it's basically choosing a number that's not nuts for the folks who have to invest millions of dollars, but it's not too conservative so that their investment doesn't work. So thanks.
There's a question right in the back, gentleman there.
No.
They won't pick it up on the internet.
To be fair to Tony, I'm not even sure this is on, who hasn't gotten a question yet.
Please hold the mic up.
We've been presenting low and high scenario emissions pathways for 50 ppm by now, and there's a big difference between 1 and 4 feet of sea level rise to places like Miami and New Orleans, New York, and even Boston, and yet maybe the lower emission scenarios, which we've never seen, we've always been on or above the top scenarios for the past years. Are we doing a disservice by even presenting the more optimistic lower emission scenarios that cause people to say, well, there's some hope. Here's some false hope that we'll have only 1 foot instead of 4 feet in terms of adaptation measures.
See, is there any questions from this? Oh, sorry.
So no, that's okay.
Sorry.
It's a shame that we're out of time. So Dork, I think the question is a disservice to whom? If you're really thinking about what you need to do to prepare for change, then I mean, as we heard last night, it's sensible to plan for the lifetime of the infrastructure that you're concerned about, and as we just heard in the discussion, to think about scenarios that are reasonable with respect to what we understand about the science and what we can actually see from measurements, and are also reasonable with respect to the amount of risk that we are willing to tolerate, both financial risk and risk to livelihoods and so forth. I think and this is part of why it's such a difficult communications challenge. The other reason, I think, for doing all these different emission scenarios, whether they're lower scenarios or higher scenarios, is also to illustrate the degree of choice that we have about the use of technologies and practices to actually affect how the climate system actually evolves. We have technological choices. There are economic choices. We have a fair amount of choice still in the kind of world that we will actually, or we or our children will actually experience, and that's important, I think. It's important to understand from an analytical perspective, from a scientific perspective. It's also important to understand from the perspective of trying to craft solutions. It is worth remembering that, for example, in the low scenario that I showed, that we looked at in this last national assessment, that is still a world that on average is about 4 degrees warmer than today. It is a very different world. One of the conclusions that I've reached, and many of us who've done a number of these scientific assessments have reached, is that we are seeing impacts, whether it's forest fires, pests, sea level rise, what have you. We are seeing impacts in today's world that 15 years ago we would have projected to be 50 years out. Things are happening faster, they're happening more rapidly, and they are larger than we had thought they would be. I think just as a scientist, it's a really important lesson in humility about the quality and character of some of the modeling that we do. And as a citizen, it's a matter of some great concern that the world is changing faster than we had imagined it would.
Any other responses to that?
Yeah, I think you need the low emissions scenario to give people something to shoot for.
Sorry for being the absent-minded professor there on that one. Here we have Dennis Carlberg.
Yes.
Yeah, please.
I'm Dennis Carlberg, the Sustainability Director here at BU. I have a question about the China-U.S. deal that was made for climate. And if that deal were to work, and as described, and everybody else followed along. I'm trying to look for the optimistic scenario here. How would that project relative to the range? Tony, I think that would start with you, but it'd be interesting to hear other panelists talk about that.
One of the conclusions of the chapter on mitigation in the National Climate Assessment that I didn't talk about, just simply because it takes too much time. There are a whole number of projections, calculations about the carbon cycle that suggests that in order to hold average annual warming globally within the sort of 2 degrees range, we would actually have emissions of carbon dioxide would have to peak within the next decade to 15 years, and then begin to decline almost to zero by the end of the century. We are on pace we're nowhere close to being able to do that. The really fascinating thing about the U.S.-China Accords, to me, both politically and scientifically, actually is China's pledge not to allow their emissions to rise after 2030. Now, they haven't said what the number would be at 2030, just whatever it is at 2030, it's not going to get any bigger. But you have to start somewhere. I did an interview somewhere about this the other morning, and I think one of the things we have to remember is that for agreements like this, they're tremendously complicated. This agreement, I think, is aspirational. It's aspirational in a really important way. China and the U.S. are the top 2 national emitters of CO2, which is by far the most, means they're the top 2 national emitters, basically, of greenhouse gases. For them to have reached this agreement on goals is, I think, a tremendously important sort of pull on the rest of the world. It's an agreement that will need an awful lot of hard work to make real. Right? This is just, it's aspirational. There's now, President Brown talked about trying to be both a visionary and a mechanic. This needs a lot of mechanics to actually be effective.
Yeah,
Follow-up comments?
If I could just add, one of the interesting things that we're now realizing is that, our future climate really depends on how much carbon dioxide we emit, the cumulative amount of fossil fuels that we burn. And one of the things that is, the reason that's true is because of the very long lifetime. As Tony said, about half of what we emit gets taken up fairly rapidly. But the long lifetime of carbon dioxide, so it will take decades to centuries out to millennia to draw that carbon dioxide down. So I think there's very strong science to underpin the importance of the mitigation side. Anything that we can do to reduce emissions now, sooner, has a very long tail. And particularly for things like sea level rise is very sensitive in the long out years to how much carbon dioxide to emit. So I'll let Tony solve the political problems, but the science is very clear that any carbon we can keep in the ground and not burn, because it's such a long-lived gas, it's really important to get to that objective.
So I have a question to the panel, and so much about the science and political and community engagement dimensions of this relates to the words and the lexicon of climate change. And something that was striking from the Mayor's Roundtable yesterday compared to this panel was that yesterday there was, I think, consensus among the panel that the term global warming was maybe a mistake in that when there's a very cold spell, people will say, oh, well, what happened to global warming? But I heard today quite frequent use of that term global warming. And I wonder if it's really more about that the ocean warming as a distinct term from global warming, given the inertia of the ocean system. But I just wanted to throw that out to the panel as, the words that we use, and that term versus climate change, global warming.
Yeah, I had sort of an epiphany about that last night, actually, in the discussion. I've long thought that global warming is an adequate term to describe this, but it's not the whole story. It's human-caused CO2 emissions cause global warming, cause climate change. And the reason global warming is an incomplete term is because I think people have a hard time connecting to it. The story you mentioned is a perfect example. Well, if it's warming, if the globe is warming, why am I cold right now? Climate change, I think, has a lot more potential to reach people. And, as scientists, I think we often default toward terminology that we find to be the most exact and the most complete and carefully crafted. But in doing so, I think we often lose our public audience. And what we really need to be thinking about is how to communicate not just with each other, but with the public as well. And so I'm a new convert to the word climate change.
Other responses or?
In spite of Scott's vote of confidence, I'm sure that I'm not going to solve any of these problems. I thought that was a really interesting discussion last night about what resonates. I mean, and I think that as scientists, almost none of us are trained to do this kind of communication. This was not a course that any of us took in graduate school. This was not we learned how to lecture and present the results of individual studies using in a sense, a standard terminology, a technical terminology, a jargony terminology that was perfectly understandable to our peers. And to be precise in the use of that language because our scientific peers would then understand exactly what we said. This is not the way to go give a public talk. And so I think there's now actually sort of a growing body of study about sort of how to communicate, which we would probably all do well to pay attention to and to practice. It's I think the main challenge is how do we best tell people what we know? It's not necessarily our jobs as scientists or as academics and professors, it's not necessarily our job to change people's mind. It is our job to tell them the truth, and to tell them the truth in a way that people can understand.
Thank you.
I like to say that in graduate school, I spent 8 years learning how to talk to other scientists and forgetting how to talk to everybody else.
There was questions in this area here in the front. Please wait for the mic. Right here in the front. Oh.
Giovanni Cecconi from Venice, Italy, one of the most threatened cities in the world. I have a question about the variability of the carbon budget, because there has been some information that the biosphere can react in a way to absorb and act as a real sinker. So there is any new data or evidence of this?
Yeah, so that you actually, if you see that red curve, you actually see the little wiggles if you're close enough to the screen. That's actually the biosphere breathing. The northern hemisphere, it takes up carbon during the spring and the summer and it releases it. But the amount that it takes up and releases each year isn't the same. And so, for example, as we're head into potentially an El Nino year with changes in water supply and rainfall all over the globe, we can document these variations on relatively, year-to-year variations. What we've been able to do with data over the last, say, half century is really piece out how much of what we're seeing in the atmosphere is due to fossil fuels, how much of it is due to land use, for example, deforestation in the tropics, how much is caused by the ocean. And what we're left with is there's still aspects of the land biosphere that we don't fully understand. So we can constrain that from observations, but we still don't fully understand all the mechanisms. You know, Tony had a slide where he had the forest taking up some carbon, and he had agriculture, and then he had other, and he had a pretty big uncertainty bar. And that's still an active area. And so when we look to the future, there's still some uncertainty. You know, if you tell me how much fossil fuel you're going to burn, I can give you some idea of what atmospheric carbon dioxide levels will be, but there's an error bar on that. And a lot of that is because we don't fully understand what happens with plants and soils.
So there's also a long perspective on this problem. So if you think back to what Josh talked about, you know, how has the world actually changed since the last big ice age, since the last big glaciation? One of the really fascinating features of the carbon cycle is how stable it is. In these periods between ice ages, the warm periods like we're in now, without fossil fuel combustion, the concentration of carbon dioxide in the atmosphere is remarkably stable for a really complex dynamic system. Goes around 280 parts per million, maybe up to 290, but it's in this very, very small range. It's not until we actually started burning large amounts of fossil fuels and essentially releasing all this old carbon into the atmosphere that we've actually perturbed the carbon dioxide concentrations in the atmosphere to their current levels. We're at about, I think NOAA just released data last week that suggested that we're like at 399 parts per million. We're essentially at 400 parts per million. We have not seen CO2 concentrations that high in the atmosphere for hundreds of thousands of years. This is well outside the range of natural variability. It's not volcanoes, it's us. That's, even as we struggle to understand the details of exactly how the biosphere is working, how much forest are we cutting down, you know, what's happening with soils, these long-term trends are really quite clear.
Yeah, actually, just really quick, can you guys put the slide back up on the screen that's up right now? The red curve.
I can't see it.
Oh.
That one. Yeah, so essentially the red curve is the residual of what we're putting in the atmosphere and what nature is taking up. And so the little bumps and wiggles are nature, and the overall increase is us. So you can't ask nature to make up for that giant increase we've added.
Time for one more question. Professor Doug Zook in the back. Please wait for the mic.
Okay, thank you. Yeah, this is Douglas Zook, Global Ecology Education Initiative here at BU, and I just wanted to emphasize that I think a lot of the point that we're going in, the direction we're going into, is really a transition from, as you mentioned, communication. And as I look around the room, I don't see folks that I work with from, you know, obviously it's not this kind of a meeting, but I work with in Winthrop and East Boston and Dorchester and so on. We need to have a transition, wouldn't you agree, from this knowledge that's here to those local communities, to those citizens. Just seeing what's happening in Newburyport and Plum Island, where houses have fallen into the sea, as you know, in recent years. There's actually some rebuilding going on the dunes, along with jetty rebuilding and so forth. So my question is, how do you see, and you've mentioned already communication, and I do think the emphasis needs to be more on mitigation at times, which leads to more effective adaptation. How do you see this divorce between our world here and what we're seeing is very clear, and reaching the people along the shore, the communities along the shore that are not hearing this and are not seeing this? How do we close that gap?
So, can I
I'd
start?
be happy to. Oh, sure.
Can I? Okay, yeah. So, Doug, I grew up a couple of miles from where one of Erika's slides was, on the New Hampshire seacoast, and you know, about every few years there's a northeaster that's big enough to just tear the bejesus out of Route 1A and toss some fishing shacks on the other side of the road. And in New Hampshire, the state owns the beachfront property, and so if it happens infrequently enough, then all the towns along the beach go to the state legislature and they'll appropriate a little more money to fix things up. if that starts happening more frequently, because there will never be income taxes in New Hampshire, as everybody here knows, as that happens more frequently, the ability to get resources to rebuild becomes harder and harder and harder, and eventually you need Plan B. And so I think we don't know what Plan B is yet, but I think what you're talking about, I think, is at what point does the kind of academic interest and knowledge actually start to match up with people's experience, so that we can collaborate rather than talk past each other. And I think that's the challenge, I think, that we all face. Stay the rest of the day. I think we're going to hear a lot about that in subsequent panels.
Erika, your video and your talk spoke much to that, so why don't you have the last word on that?
Sure. No, I'd love to weigh in. I live right near Newburyport. I'm in Amesbury, Massachusetts right now. And what I'm seeing is that communities that are relatively more affluent and have the capacity for, sort of civil society groups to come together and organize and really push local leadership, they're seeing accelerated planning processes, accelerated, community dialogues to really start to grapple with their risk. I think we're going to need resources to help other communities that are more beleaguered, frankly, by too many other things, to to pull together the kind of really thoughtful, deep, long horizon planning processes that are going to be needed for building resilience in a meaningful way. I also think we're going to have to find ways to reform disaster recovery in this country. Because we're currently, by and large, rebuilding things in place as they were before, as opposed to, we're talking a good talk about resilience and making some incremental changes, but we need to really look hard at the current system and do the hard work of not putting, good money after bad and reinvesting in things that are going to be torn down in the next disaster.
So our keynote and panel has really set the stage for the rest of the day excellently, and so we're going to take a 10-minute break and come back and learn about the public sector response and adaptation. And so let's thank our panel and be back.